All right, I believe these are medium difficulty problems. And that's where I think we should focus today.
Okay.
Okay, not on easy, not on hard. I think you'll get most of the easy ones. You'll probably miss most of the hard ones. So what we want to do is get you to get the medium ones.
Okay.
Number 8.
How many pieces of wire are possible are cut from a wire? What is 6 feet long? What is the total length of a wire that is left over? Pieces of wires are possible to tie.
Now, why did they give you this last piece of information?
Because it shows how much a foot is.
That's measured in inches and that's measured in feet, so you're going to have to make the conversion.
Yeah.
Which is easiest to convert to?
The inches to feet.
No, not really. That's 7/12 of a foot.
Oh, yeah.
So that is 6 feet times 12 inches. So 6 feet times 12 inches per 1 foot, that is 72 inches. So now you've got 72 inches divided by 7 inches. What's left over when you do that division? And this
10.
is actually not. When you do it on a calculator, what do you get?
10.28.
That's what's left over.
Okay.
But the other way to do it is long division. In other words, notice that it's difficult to take that answer and convert it into how many inches were left over. But if I merely divide 7 into 72, I get remainder of 2. In other words, this is a perfect problem that shows you, and this problem is on every SAT test, where if you use the calculator, you're going to have a decimal answer. And they don't want a decimal answer. They want a number of inches. Okay? What this tells you is that you're going to have 10 pieces of wire with 0.28 wire left over. Well, if you multiply 0.28 times 7, you'll get something close to 2.
Okay.
So, but that's a lot harder than just doing the long division. So remember that when they ask about leftovers, remember that sometimes the long division is better. Let me give you an example. You have 2, hold on. So we're going to do 9 next, but before we do it, I want to give you a very similar problem that I've seen on another SAT practice test. So I know that they put these problems on every single test, and they all share one thing in common, that if you do them by calculator, you're not going to get the right answer, but if you do them by long division, you will.
Okay.
You have 224 chairs that are to be placed at 20 tables? How many chairs do you have left over?
Um, 20.
What do you get
4.
on your calculator?
11.2.
That doesn't tell you how many chairs you have left over, does it?
Yeah.
So now do it by long division.
I got a remainder of 4.
That's how many chairs you have left over. Okay. Notice that you could get it easily with long division, but it's rather difficult to get using a calculator. And that's not uncommon. They do not like to give you an advantage using a calculator. They would rather reward people who know how to do long division. All right, let's look at number 9. Only I've got to scroll up just a little bit. All right, number 9.
Which the in the figure above has the coordinates x1, which is x plus 6.
Okay, there's 3 solutions, techniques that you can use. You can use
Okay.
algebraic. Can you do the algebra on this one?
Yes.
I'm not sure I can do the algebra on this one.
Okay.
Can I back solve it? Definitely yes. If somebody said you will live or die depending on whether you get this problem right, I'm back solving it because I can figure out what the coordinates of A are. What are the coordinates of A?
4 and 1.
That's -1, 4. Okay, you got to get the signs right. If your life depended on it, you're dead if you said 4, 1. They're not 4, 1. They're -1. That's the x-coordinate. The y-coordinate is 4. Now, does that equal 6? In other words, is the absolute value of -1 plus the absolute value of 4, does that equal 6?
No.
That's definitely not right. How about B? What are the coordinates of B?
-4 and 2.
Is the absolute value of those two numbers equal to 6?
No.
Now, hold on.
Oh, wait.
What's the absolute value of -4? It's always the positive number. That's the only thing absolute value means, is it doesn't matter whether the sign is positive or negative, the answer is positive. So the absolute value of 4 is 4. The absolute value of -4 is 4.
Okay.
Bingo. We found one that works. Are we done with the problem or do we have to go further?
We're done with the problem, I think.
Yes, there's always only going to be one answer that's correct. Unless it's a kind of a problem that it says which of the following are not correct, and then 4 of them would be correct and 1 wouldn't be. But in this case here, that's all we have to do is find one where that's true. There is no way that they are putting 2 correct answers on the same question, ever, unless it's a typo. because then they wouldn't be able to score it. They can only score it if there's only one correct answer.
Mm-hmm.
So let's look at number 10. What we have are two sets, set A and set B. This is a peculiar subject for them to test on. Nonetheless, let's look at it. And whenever you see a problem like this, it's really three problems in one. What you have to do is say true or false to each of those three. And then once you get the true or false to each of them, you can pick the correct answer. Okay?
Okay.
So, N is a member of both set and set B, set A and set B. So let's find all the members that are members of both.
3/5, 4, and 8.
So N has to be a member of both. So N equals 3/5 or 4 or 8. N is an integer, true or false?
True, I think.
I know your terminology. Do not forget your terminology. Integers mean whole numbers. No fractions, no decimals.
Then it's not.
That's true, because 3/5 is not an integer. 5n is an integer. 5 times n.
False.
Well, what's 5 times 3/5?
Oh, 3, then yeah.
N equals 5.
Hold on. N equals 5. False?
Yeah, 5 isn't a member of that set. In other words, this is the set we end up with when we're looking for numbers that are members of both sets. This is the set we end up with, and 5 is not in there. So the only thing that's true is 2 only. So answer A. But you can see that you have to answer all three questions. So it really is 3 questions in one. Number 11.
Correctly. When x equals 6.
On these kind of problems, you really have to know the general formula. If you don't, you really don't have anywhere to begin. Okay?
Okay.
So when they say y is directly proportional to x, that has a very specific meaning. It means this. If they say, that's direct proportionality. If they say that y is inversely proportional to x, it means this, where k is some constant that we don't know, but they're going to give us enough information to figure out k. Okay? So let's go with the first one. Direct proportionality means that. Now, they say if y equals 30 when x equals 6, what can I say? That's going to allow me to calculate k. What do I have to do?
So put in 30 for y, and then equals to 6
What's k equal?
times k times 6.
What's k equal to?
Um,
You have to do the math. You're trying to isolate k.
5.
Okay? So what's your equation?
What is the value of y? What?
In other words, once you've defined k, you always go back and use a y and an x. Your original y and x now come back into play because you know what k is. For this particular proportionality, k is 5, always. So here's the equation we're dealing with. Now the rest of the problem is easy. What is y when x is 8?
So y equals 5 times 8,
You got it.
so 40.
Uh-huh. But the entire problem rests on your knowledge of what directly proportional, so let's go through it again. Directly, and they're definitely going to ask you one or two problems on this. That means y is directly proportional to x. If I say inversely proportional, then y is some k divided by x. And notice what the difference is. This is a positive slope. As x goes up, y goes up. This is a negative slope. As x goes up, y goes down. So this one down here is inverse. This one up here is direct.
Okay.
And you do have to memorize these because these problems only come in one flavor. And that's where they tell you the proportionality, direct. You have to solve for k, always next step. Once you've solved for k, they give you another x, and you have to solve for the y once you know k. So it's those 3 steps always, every single time.
Okay.
So if you remember your arithmetic sequences, you'll remember that a sub n equals a sub 0 plus some common difference times n minus 1. What happens is that when they give you a particular sequence, you can always narrow it down or simplify it. And they're saying that it simplifies to this. Okay?
Okay.
What's the first term of that sequence?
The first term, a, or
First term means when n is equal to 1.
oh, I don't know.
Substitute 1 for n. What is a sub 1? It's 5 times 1
Oh,
plus 2.
so 7.
What's the third term of that sequence?
5 times 3 plus 2. 17.
What's the fourth term?
22.
How much separates each term?
5.
How much greater is the 30th term than the 35th term?
Wouldn't it be 5?
That would separate the 30th term from the 31st term. They're saying how much between the 35th and the 30th. How much is between each term?
I don't know.
An arithmetic sequence is by definition a sequence where every term is separated by the same amount. So if I know the difference between the third term and the fourth term is 5, then I know the difference between the 30th term and the 31st term is 5. And I know the difference between the 31st and the 32nd is 5. So what's the difference between the 30th and the 35th?
25?
You got it. Boy, these look intimidating, don't they? Notice how intimidating just based on diagrams. Even though it shouldn't be. These should not be intimidating. In fact, they should be rather easy. Let's look at it. No, seriously. Because we can see we're looking at rectangular solids there. How hard could it be? They're going to ask you the volume at most. Volume is all 3 dimensions times one another. So, real quickly, what's the volume of that one?
2 times 2. I don't know. Hold on. 2, 4, 6, 8, 12, I think.
What's 2 times 2?
4.
What's 4 times 2?
8.
What's the volume of this one?
6. 12.
This one here.
36? Wait, no. Yeah.
24. What's the volume of D? 3 times 3 times 3.
27.
And finally, E?
36.
Okay. Now, they say which one is the closest to the volume of a right cylinder with a radius of that and a height of that? Well, the one advantage you got going for you is that SAT gives you all the formulas. So if you go looking for the volume of a right cylinder at the beginning of the test, they will show you that it's the base times the height. Well, the radius squared, that's 16 pi, times the height of 2, that's 32 pi. Now, this is one of the rare instances where you've got to convert 32 pi to a number, or do you? Look at all the answers. What is the answer?
E?
Has to be. 32 pi is 32 times 3.14, so it's at least 96. And they're saying which of these 5 answers is closest to 96 and change, the biggest one. Now, did we have to do each of these calculations? I think we actually did. But the problem is that they were really easy to do. We did not need a calculator. We could just multiply these three tiny numbers times each other. So it was real easy to do that step. The hard step was this one.
Yeah.
But once you get it down to 32 pi, now you don't even really have to go any further. 32 pi is clearly closest to 36. All right, number 14.
As a negative integer, what is the origin of r, s, and t from least to greatest?
Integer again means what?
Like a whole number.
Okay. Negative integer, just to refresh you. Positive integers are 1, 2, 3, 4, 5, and so on. Negative integers are -1, -2, -3, and so forth. 0 is neither negative nor positive.
Okay.
So when they say n is a negative integer, then our possibilities basically are -1, -2, -3, so forth and so on. Okay? So, r is equal to a negative integer cubed minus 0.61.
Minus the 0.61.
Let's not start with r. It's actually easier to start with s.
Okay.
Is s positive or negative?
Negative.
No.
Wait, how can you tell?
Well, because you're taking a negative integer and you're squaring it, which means it's going to be at least +1 or +4 or +9. So if the lowest that this can be is 1, then minus 0.61 means that that's going to be either 0.39 or possibly 3.39 or bigger.
Okay.
See why? Remember that -1 squared is +1.
Okay.
Okay. Now, let's go down to t. Here, if n is -1, then this becomes -1 minus 0.61, which is -1.61, but then the whole quantity is squared, so that's going to be bigger still. It's going to be a bigger positive number. I don't know what 1.6 squared is, but it's at least 2 and change for the first one. And then if n is -2, it's like +5. And if n is -3, it immediately goes up to like +11. So t is also big. In fact, at this point, t is bigger than s no matter what n is.
Mm-hmm.
Right? In other words, t is bigger than s, t is bigger than s, t is bigger than s. Now, let's look at r. When we cube a negative number, it stays negative. If I say -2 cubed, it's -2 times -2 times -2. That's -8. So
Okay.
if I start with a negative integer and cube it, it stays negative. It's either going to be -1 or -8 or -27. So our possible values are -1, -1.6, if I make n minus 2, then it's negative 8 and change, and negative 26 and change. Okay? So now, here's the three numbers we're comparing. Rate them in size. Which is the smallest?
R.
Which is the next smallest?
S.
And the last?
T. Okay.
All right, Haley, I got a 4 o'clock, so I got to run.
Yeah.
And, gosh, good luck on your test tomorrow. That's going to be grueling. Get a good night's sleep. That's the best advice I can give you. Don't cram. Don't cram. This is not the time to cram.
Okay.
Okay? Make sure you get a good night's sleep and have a decent breakfast in the morning so you'll have what it takes to do your best.
Okay.
All right, Haley. Good luck.
Thank you.
Bye-bye.
Bye.